Bam, Mr. True. So, we found derivatives using the basic rules. We talked about the quotient rule, we talked about the product rule, and yet there's still some problems that we're not capable of finding the derivative of, some functions. So we're going to bring in another rule called the chain rule. If y equals f of u is a differentiable function of u, and u equals g of x is a differentiable function of x, then y equals f of g of x. We have a function nested inside of another function. I'll do an example to show you how's this different, or what's that going to look like, how's that compared with our old questions we've already taken a look at, is a differentiable function of x. So, the derivative with respect to x of f of g of x, this is going back to our old concepts of composite functions, is equal to f prime of g of x. So we found the derivative basically of the outside function and left the inside function alone, and then multiply by the derivative of g of x, where we actually take that inside function out and find its derivative. Or we let u equals g of x. We can do a substitution like this to make the question, it's not really necessary unless rewriting the equation, rewriting the function, excuse me, just by making it look a little bit simpler helps you understand how to work through the problem. So you can do a temporary substitution where you go, okay, let's let g of x, maybe it's a really complicated function inside of another one, let's let g of x just simply equal u. Well, then we have y prime, the derivative of y, is equal to f prime of u times the derivative of u. So you'll have to go back when you're done and plug back in that original, more complicated expression that you used that you substituted out. But maybe this process will help you, finish the problem, more accurately and easier. I'm probably going to be doing most of my examples in this format, though. And what we're doing is we're finding the derivative of y with respect to x, and we're walking through that middle function. We're finding the derivative of y with respect to u. That's that inside function. And then we're multiplying the derivative of u, the derivative of that inside function, with respect to x. And we're going through this chain, until we get back, until we get that derivative of y, the derivative of the original function, with respect to x. So, what are these examples going to look like? Let's find out! Bam! In our first two examples, we have here f of x is equal to x squared, and f of x is equal to parentheses 3x squared minus 4x squared. Well, the first one's very simple. That's just the power rule. F prime of x is going to be equal to 2x. Whereas the second one here, I have something going on inside the squared function. So this is a function inside of another function. We haven't had that before. So if I were to solve this, or if I were to find the derivative of this without using chain rule, then I would have two options. One, and that's the first one I'm going to do, is this binomial is being squared. So I can write 3x squared minus 4x times 3x squared minus 4x. Now, if I wasn't about to go over the chain rule with you, I would distribute this and make a polynomial and then find the derivative. But I want to match the format of the answer I'm going to get when I use the chain rule. So I'm going to leave this like this and use the product rule to find this derivative. So that is going to be f prime of x is equal to 3x squared minus 4x times the derivative with respect to x of the second factor. So that's going to be 3x squared minus 4x. I'm just showing all the steps here. Plus, now we're going to take the derivative of the first factor. So the derivative with respect to x of 3x squared minus 4x times 3x squared minus 4x. Now, this derivative we have here, 3x squared minus 4x. The derivative of 3x squared minus 4x is going to be 6x minus 4 plus the derivative of 3x squared minus 4x is, again, we're using power rule and constant multiple rule. This is going to be 6x again minus 4 times 3x squared minus 4x. Well, now I've got two terms that both have the same factors in them. They're in a different order, but multiplication is commutative. So we have something times something else plus those same two somethings still being multiplied together. So if I said like xy plus yx, that would be 2xy, and indeed that's what we have here. This comes out to be 2 times 3x squared minus 4x times 6x minus 4. So now that I've found the derivative using a rule that we already know, let's apply the chain rule and see what happens. So we're going to use this example again. F of x is equal to 3x squared minus 4x squared. This portion, this is my u. Okay, that's the function that's inside the other function, this power of 2 function. So this is my u, or this is my g of x. Okay, and this outside function, this something squared, that's my f of x. So let's write that as a y, make sure you don't get confused with my notation here. Okay, so y prime is going to be equal to, I'm going to use the power rule, because this is something squared. So just like I had here something squared, I'm going to take the power of 2 and drop it down out front and reduce the exponent by 1. So we're going to have 2 times 3x squared minus 4x, and that's raised to the first power, which doesn't do anything, but I'm writing it because I'm teaching it. That is the f prime of g of x. Now I got to take the inside function out and find the derivative of that. And again, I'm going to write this out all in tiny little steps because I'm just now, you're just learning it for the first time, I'm assuming, watching this video. So we're going to take that inside function out and find the derivative with respect to x of 3x squared minus 4x. Okay, so now we've got 2 times 3x squared minus 4x. We're going to find the derivative of what was the inside function, the derivative of g of x, or the derivative of u. And that's going to be, okay, we have a power rule, so that's going to be 3 times 2 is 6x minus 4. And voila, it's what we got by when we use the product rule. So that's sort of validation, certainly not proof, but it's validation. We've done the same, we found the derivative of the same function twice, got the same answer. So hey, this must work, and look how much less work that is. The chain rule very, very often is going to be a huge time saver, and sometimes it won't necessarily be, but a lot of times it will keep the notation a little bit simpler. We're going to do a lot of examples in this video to make sure you know how to do it yourself. Bye! That last example I just went through follows what's called the general power rule. And it says if u is equal to a function inside of a power, where u is a differentiable function of x and n is a rational number, so it can be like square root of 7 or something like that, then the derivative of y with respect to x is equal to n times u of x to the n minus 1 power, just taking that power out front, reducing this by 1, and then multiplying by the derivative of function u with respect to x. Or in simpler terms, the derivative with respect to x of u to the n is equal to n times u to the n minus 1 times u prime, or the derivative of u. Just a special case of the chain rule, where you have powers. They follow this nice and easy pattern. We didn't really need to know that to finish that last problem. It should be, kind of ingrained with you, inside of you, after using that power rule, except, it's just the power rule and the chain rule combined together. So here we have f of t is equal to the square root of 4 minus t. Well, again, we don't like really working with radicals, so I'm going to rewrite this with a fractional exponent. That's going to be equal to 4 minus t. It's raised to the first power, which you don't really need to write. But the root is the second root, so square root. So we do need that exponent, and it is equal to 1/2. So we have 4 minus t to the 1/2 power. So f prime of t is equal to 1/2. We're going to bring that out front. So 1/2 times 4 minus t. This needs to get reduced by a value of 1. So 1/2 minus 1 is negative 1/2. And we do not want to leave negative exponents in our final answer. So we're going to take this this binomial that has that negative power and drop it down into the base of the fraction. Now, along with it inside the denominator, we already have a 2. So we're going to have 1, that's this 1 here, 1 over, there's already a 2 in the denominator. Now see, because this is 1/2 times this. So this is really, kind of like, well, it is, over 1. So that would be 2 times 1, but not anymore, because the 4 minus t is going to get moved down to get rid of that negative exponent. And it's 1 over 2 times 4 minus t to the 1/2. And that's perfectly acceptable to leave it in that format. Or if you want to put the radical back in, because that's how the problem started, that's going to be 1 over 2 times the square root, of 4 minus t. Next example. So for our next two examples, we have f of x is equal to 2 over 3 times the square root of 2x minus 1, which we're going to immediately change to be 2 over 3 times 2x minus 1 raised to the 1/2 power. Now I don't want to leave this question in this format because I don't want to use the quotient rule. So what I'm going to do is, because I have this 2x minus 1 in the denominator, so I'm going to bring this binomial up into sort of like the numerator and write it as 2/3. Let's see, I got some room here. 2 over 3 times, and I'm going to let that 2x minus 1 come up, and now I'm going to have that exponent of 1/2 become negative 1/2. And so we kind of have, again, a yet another step more difficult, another example of using that general power rule. So we're going to, now this in here, if you're doing your substitution, this is our u, okay? This is our inside function. I'm going to apply the power rule, so we're going to do negative 1/2 times 2/3, which is going to be negative 1/3. So f prime of x is equal to negative 1/3 times our inside function of 2x minus 1. We're going to let that denominator be reduced by 1, so it becomes negative 1/2 minus 1 is negative 1/2 minus 2 over 2, so it's going to be negative 3 over 2. And then we need to, do that derivative, take the derivative of this inside function. So that is going to be the derivative of 2x minus 1 is going to be equal to 2. So this is the u, and this is the derivative of u. Okay, well, this 2x minus 1 has a negative exponent, so I'm going to let it float down to the base, and get the 2 is just sitting there, the 2 is over 1, so this is going to become negative 1 times 2 is negative 2 over 3, and this binomial with the negative exponent is going to get floated down, so we have 2x minus 1 to the now positive 3/2 power. And that can be rewritten, if you like, as f prime of x is equal to negative 2 over 3, that's a power and a root, so square root, so 3 times the square root of 2x minus 1. And I don't want to publish something that has a mistake, so let me just double check my answer. And we have a power of 3, and we're good. That's the derivative. Now, over here, we have what will be eventually a very similar situation. I do not want to handle this fraction in this fashion. I can very, very easily, because this is just a 1, I can rewrite this so I don't have to apply the quotient rule as it sits right now. So I'm going to take that base, that binomial in the denominator of 2t plus 3, bring it up to the top, and that's going to be 2t plus 3. Now, that whole binomial that's in the denominator of the fraction, and fraction bars do act as a grouping symbol, so it is a binomial in the denominator. As I float that entire denominator up that has an exponent of 1, or I need to assume it has an exponent of 1, that will now become 2t plus 3 to the negative 1 power, and then the original function, of course, was raised to the second power. So now I have something raised to a power to another power. So this is power to power. This is, when you have stacked exponents, you should be multiplying them. So this is going to become f of x is equal to 2t plus 3 to the negative 2 power. Now this problem is starting to look like all the other ones did. I'm going to apply the general power rule, which means that f prime of x is negative 2 times 2t plus 3 reduce that exponent by 1, so that'd be negative 3 now. And this is my inside function. This is something raised to a negative 2. So now that inside function, that g of x or that u, has not been, we have not taken the derivative of that yet. So that needs to be found. And that derivative of 2t plus 3 is going to be equal to 2. So again, this is my u inside here, and this is my u prime if you want to do those substitutions. Alrighty then. Well, the only thing with the negative exponent is the 2t plus 3, so that's going to get moved down. This is negative 2 over 1, this is 2 over 1, and just this base with the negative exponent is going to come down into the denominator. So we get negative 2 times 2 is negative 4 over 2t plus 3, now raised to the third power. Double check it, and we are good. I've got 2 more examples. They're quite advanced. I think what I'll do is, let's go ahead and stop this tape here, video, in case you don't need it to see anything more difficult. And the next example, or the next video with 2 examples, will involve the combination of chain rule and the quotient rule, and maybe a little bit of nested chain rule, where you have to go through that process a couple of times. So if you're good here, thank you for watching. If not, the next video will have 2 more advanced examples if you need them. I'm Mr. True. Go do your homework.